These are the answers to homework pages 456 and 457, Unit 13, Lesson 3. Number 1, your values in line with the normal curve at a z-score of 0, 1,980, z-score of 1, 2,270, 2,560, 2,850, z-score of negative 1, 1,690, negative 2, 1,400, negative 3, 1,110. 1B, 1, z-score is negative 0.6, and the value 1,800 would be about here. 2, z-score negative 1.7. The value of 1,500 would be about here. 3, z-score is 0.4. The value of 2,100 would be about here. C, the z-score is approximately 1.8. And the answer is no. The z-score of 1.8 is less than 2, so it is considered a typical value. It is not an extreme value. Number 2, A, the value is 67%. B, the value is 37%. And C, the value is the mean, 60%. Number 3, A, 94 to 116 minutes. B, 83 to 127 minutes. And C, your answers could vary. It would be any time outside of the 83 to 127 minutes from above. So I said 70 minutes, 130 minutes, 80 minutes, 138 minutes. So any number of minutes that are either less than 83 minutes or greater than 127 minutes. Now for explanations in Week B. For A, a z-score of 0, you would place the mean, which was the 1,980. And if their standard deviation is 290, then a z-score of 1 would be the mean plus 1 standard deviation. So 1,980 plus 290 is 2,270. That would go in line with 1. And then in line with 2, you could just take this value and add another standard deviation to it. 2,270 plus 290 would bring you up to 2,560. A z-score of negative 3 would be the mean minus 3 times the standard deviation. So I could just do that on the calculator. I take the mean of 1980 and subtract 3 times the standard deviation of 290. 1,110. B, the work is shown. We're given the value. To find a z-score, it's going to be the value minus the mean divided by the standard deviation. So 1,800 minus 1,980 divided by 290. You get this decimal. Round it to the nearest tenth is negative 0.6. And negative 0.6 is, well, it's halfway, a little more than, or a little less than halfway, between 0 and negative 1. It's going to be a little closer to negative 1. 1,500 minus the mean, 1,980 divided by 290 is this decimal rounding to nearest tenth. is negative 1.7, which is closer to negative 0.2 than to negative 1. 3, 2100 minus 1980 divided by 290 is this decimal to the nearest tenth is 0.4, which a little less than halfway between 0 and 1. Halfway between would be 0.5, so it's just a little less. C, the z-score for this charge, for this value, is approximately 1.8, right? Value minus the mean divided by the standard deviation. And as long as your z-score is between -2 and +2, it is typical, right? If your z-score is between a -2 and +2 value, which 1.8 is, then it is considered typical. Number 2 is more work with z-scores. Here, given the z-score, you want to define the value, so you're still using the formula. So the weighted coin lands heads on average. Okay, so the average is 60%. So that means the mean is 60%, or the decimal point 60. And this is normally distributed. Standard deviation is 10%, or 0.10. Find the data value that corresponds to a z-score of 0.7. So the z-score 0.7 goes in for z. 0.7 equals the value minus the mean 0.60 divided by the standard deviation 0.10. So we're just solving this for b, and instead of b you could have used x. So multiply both sides by 0.10 to get rid of this division, and we get 0.07 equals the value minus 0.60, so add 0.60 to both sides, and we get 0.67, which is the same as 67%. Similarly for b, again, we're given the z-score. The negative 2.3 goes in for z. We're trying to find the value minus the mean 0.60 divided by the standard deviation, multiply by 0.10. You get negative 0.23 equals the value minus the mean, so add the mean, and you get 0.37 is equal to the value. So 37%. Find the data value that corresponds to a z-score of 0. Well, a z-score of 0 is the mean value, which is 60%, so no work to be done there. Number 3, suppose that the durations of high school baseball games are approximately normally distributed with a mean of 105 and standard deviation of 11. Use the normal curve on page 453 to give a range of baseball game lengths centered around the mean that would be expected to occur 68% of the time. 68% of the time was the that was within 1 standard deviation of the mean. So we would want to take the mean plus or minus 1 standard deviation. So that's what we did here, the mean plus or minus 1 standard deviation. So 105 plus 11 is 116. 105 minus 11 is 94. So what would we expect to occur 68% of the time is a time length or a game length of 94 to 116 minutes. B, use a normal curve on page 453 to give a range of baseball game length centered around the mean that would be expected to occur 95% of the time. That's within the 2 standard deviations, so that's going to be the mean plus or minus 2 standard deviations. So we take the mean of 105 plus 2 times the standard deviation of 11. That's 105 plus 22, which is 127, and 105 minus 22, which is 83. So anywhere from 83 to 127 minutes. And again, choose a length of baseball game that would be considered unusual Unusual is anything outside of that mean plus or minus 2 standard deviations. So anytime outside of the 83 to 127. So you can have any time length that is not within this range would be considered unusual. So again, the answers can vary.